Okay, so this is the next step of the experiment. The unknown solution has been prepared. In the last video, I used a 100 milliliter volumetric flask. I reread through the procedure, and I actually needed a 250 milliliter volumetric flask. So, I mean, it's the same procedure, just a different amount of solvent. Again, just same procedure from the previous video, but instead of using the 100 milliliter volumetric flask, we're using the 250 milliliter flask. So this new solution has been prepared using the same method in the previous video, and now I've transferred 25 milliliters of the unknown solution to this Erlenmeyer flask and added 10 drops of the indicator, and now we're titrating this with hydrochloric acid, the 0.3 molar hydrochloric acid solution. And again, we're looking for a color change from this dark blue to a green teal type color. So with that first unknown solution that I prepared using only 100 milliliters, I actually did run this titration and got a color change at around, was it 31 milliliters of hydrochloric acid titrated. This is a more dilute solution, so I'm thinking it should require less hydrochloric acid for this titration, because it's all dependent upon molar ratios, right? And when you use the same amount or same mass of solute and a greater amount of solvent, you're decreasing the molarity. And since the molarity has been decreased, then the amount of hydrochloric acid needed to neutralize the solution should also decrease. If that makes sense. Again, you all are upper level undergraduate students, so that should make sense to you. You should be able to understand that. I'm going real slow with this first titration, so my endpoint value will be as precise as possible. To me, it looks like I'm seeing the color is trying to change. I'm looking at it from a different perspective. I think it's a little easier to see from this top view than it is on the camera, but whenever the end point is reached, it'll be obvious. This dark blue is going to change, like I said, to a teal type of green. I don't know if you can see the rate of the drops, but it's like 1 drop per second. That's the rate you want to go at for your initial titrations. You want to go real slow on the first ones, I'm getting real close to the end point. I don't know if you can see it that well on camera, but I can see the solution trying to change colors. So I'm slowing it down to like maybe still about a drop per second, and now I know you're able to see as well a slight color change. I mean, it's still slightly blue, but it's more green now than blue. Honestly, I'll add one more drop, and then I'm going to compare it to this other blue, and it should be obvious at that point that this is green. Okay, see, I actually went too far in this titration. This is now yellow, so we've gone past the end point at this point. That's more yellow than green. I should have stopped it at that last point, but you know, for purposes, just for like visualization purposes, and you can see the difference. Like this is acidic. This has gone past the titration point. I should have stopped it initially and showed that green compared to this blue. But I'm gonna do another titration. So according to this, like this initial titration, if we use the same amount of volume of the unknown solution in this same hydrochloric acid solution, we should only need to titrate approximately 10 milliliters of hydrochloric acid to the unknown solution before it reaches its titration endpoint. So now that we know that, I'm still going to record this value and send it to you for, you know, calculation purposes. But I don't know, I'm gonna record it. We'll see if this is a value that you use in your calculations or not. But we now know that it's gonna take approximately 10 milliliters to titrate the unknown solution. So, or reach the endpoint, or yeah, neutralize the unknown solution with hydrochloric acid. So with that known information, we're gonna prepare another unknown solution and run another titration, and then compare these three different colors of, you know, this solution, and the next titrated solution in the next video.